Hey, this is Presh Talwalkar, and you're watching Mind Your Decisions. Here's a really fun problem. Solve 615 plus x squared is equal to 2 to the power of y over the integers. You're not allowed to use computers or calculators. I thank Luka Khizambareli from Georgia for suggesting this problem and for sending a solution. Can you figure it out? Give this problem a try, and when you're ready, keep watching the video for a solution. So how can we solve this equation? Well, I'll admit that I did not solve this problem. So I resorted to WolframAlpha. You can solve equations for integer solutions. For example, if you type solve 3x plus 4y is equal to 5 over the integers, WolframAlpha will give you examples of integer solutions. So I thought, since I'm not able to solve this problem, maybe I can get the result from WolframAlpha. So I typed it in, and to my great surprise, it said the result is false. The examples of integer solutions it gave were not actual solutions to this equation over the integers. So this is wrong. The problem actually does have a solution. So now let's proceed to solve a problem that WolframAlpha is not yet able to solve. How can we do that? We'll start with a basic observation. Since x squared is non-negative, 2 to the power of y is at least 615. We can then conclude y is greater than 9 because 2 to the power of 9 is equal to 512. We then proceed by considering that if this equation has a solution, both sides need to have the same last digit. So we'll analyze the very last digit of 615 plus x squared. We'll start out by considering x, the very last digit it could have is from 0 to 9. So then we consider the last digit of x squared. We take the square of each of these digits and consider only the last digit. To get the last digit of 615 plus x squared, we add 5 to each of the last digits of x squared. We now consider the very last digit of 2 to the power of y. You can figure this out by doing a few calculations. If you calculate the values for y is equal to 1, 2, 3, 4, and so on, you'll see a pattern. The last digit of 2 to the power of y will follow a pattern 2, 4, 8, 6. Then the pattern will repeat 2, 4, 8, 6, and so on for every 4 numbers. Now, in order that the last digits match, we look at the last digit of 615 plus x squared, and we want to see which ones correspond to 2, 4, 8, or 6. This only happens when x is equal to 1, 3, 7, or 9, and the last digit will be 6 or 4. So for the digits to match, the very last digits, x would have to be 1, 3, 7, or 9, and y would have to be 2, 4, 6, 8, and so on. In other words, y would have to be an even number. So we've established that y is even, and that'll be the key to solving this problem. Why does this help us? Well, if y is even, that means y is equal to 2 times n for n an integer. We can then substitute 2 to the n for y. So we have 615 plus x squared is equal to 2 to the power of 2n. We then subtract x squared from both sides. And now we use a clever trick. On the right-hand side, we have a difference of squares. So we can use the difference of squares formula that a squared minus b squared is equal to the quantity a plus b times the quantity a minus b. In this case, we can factor that 615 is equal to the quantity 2 to the n plus x times 2 to the n minus x. So, we're now going to analyze 615 for two factors, 2 to the n plus x and 2 to the n minus x. We can do this by considering the prime factorization. 615 is equal to 3 times 5 times 41. So we consider which two numbers, what pairs of factors we could have which would equal 615. We can enumerate the possibilities. We can have 1 times 615, we can have 3 times 205, 5 times 123, or 15 times 41. Now, how can we figure out which possibility corresponds to our solution? Well, consider adding the two factors together. 2 to the n plus x plus 2 to the n minus x will equal 2 times 2 to the n, and that simplifies to be 2 to the power of n plus 1. So the sum of the two factors is equal to 2 to the power of n plus 1. So we now consider the sum of the factors in each of these four cases. We need it to be a power of 2. And of these four numbers, only 128 is a power of 2. So the sum of factors, if there's a solution, would be 128, which equals 2 to the power of 7, which equals 2 to the power of n plus 1. Therefore, n is equal to 6, and then y is equal to 2 times n, which is 12. Now with this knowledge, how can we solve for x? Well, we can consider the difference of factors. 2 to the n plus x minus the quantity 2 to the n minus x is equal to 2x, and that's the difference of the two factors. So now we take the difference of 123 and 5, and we get 118. That's equal to 2x, which means x is equal to 59. So if there's a solution, it would have to be x is equal to 59 and y is equal to 12. And in fact, we can verify that 615 plus 59 squared is equal to 4096, which exactly equals 2 to the power of 12. We just solved a problem that WolframAlpha is not yet able to solve, and all we did was use the principles of number theories. I think that's pretty neat. Did you figure it out? Thanks for watching this video. These math videos, which can be watched for free on YouTube, inspire and build confidence for people around the world, and they already have over 100 million views. Let's share the beauty of mathematics. With your help, we can math the world a better place. Please subscribe for free to get the newest videos, watch and share all of the videos on Mind Your Decisions, email me a puzzle or math topic, presh@mindyourdecisions.com. If you so choose, you can check out my books, which are linked in the video description, and you can support me on Patreon for exclusive rewards. Thanks for watching, and thanks for your support.